you have here in your packet, okay? For some reason, this is so hard for students to grasp, so stay with me on this. And we're going to do them all in interval notation. All right, tell me what domain represents. We talked about this yesterday briefly. Domain is the what? The x. Those are the x values, that's right. And range would be the y values, right? So if I'm on a graph, this is my x and this is my y, yes? All right. So when I'm looking at domain, since this is the x-axis and it describes x, for domain, you scan your pencil from left to right. So domain is left to right. Whereas the range would be, along the x-axis. Along the x-axis. Whereas range is from the bottom to the top. I like to say bottoms up. It helps me remember. Bottoms up of the y-axis. Okay? All right. I had 2 yardsticks in here. Y'all see them? I put one back there. Oh. So I'm going to use the yardstick. We'll use the pencil. It'll just be a little easier to see. So I'm going to put this first graph up here. It looks something like, yes? Something like that. Yes. Use Smart Path. Did you? I'm sorry, I didn't hear you. Okay, let Dustin go first, then you can go. Okay, go, Max. You can go after that. Hey, take your pencil. I don't know what all that's for. Left to right, okay? So you're going to hold your pencil like this, and you're going to scan from left to right. Is there ever any time where your pencil would not touch graph? Even if I came all the way over here, it would eventually touch that graph, right? How do you know? What's this arrow tell me? It tells me it's going up forever. Look, it's going up forever, 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 forever. So even if I'm all the way over here, it's still gonna touch graph at some point, right? So what is the furthest left my graph can ever go? Negative infinity. I start with smallest, right? Negative infinity goes to the left, infinity goes to the right. So my domain, the smallest it can be is negative infinity. Does that get a bracket or a parenthesis? Parenthesis y. Infinity always gets parentheses. Now, as I move to the right, take your pencil on your paper and move it to the right. Tell me when you've never touched graph again. Never. You're always touching graph. So what's the biggest it can be? Infinity. So the domain is negative infinity to infinity. Now the range is a little bit different. Turn your pencil the other way. What?
Look, the screen cracked. Look, there's a crack in the screen. You're okay.
What's the lowest it ever goes?
I'm gonna break it. You're doing it.
What's the lowest it ever goes? I'm getting out all my aggression today on the board.
Infinity
Hold on.
down.
My back really hurts.
Infinity down.
No, the lowest. Bottoms up. I'm fixing it.
Infinity down.
But you got to start with the lowest, -2. Does everybody see that? This point right here is the lowest the graph goes. So I talk about the y because it's range. So it's -2. Now, is it a bracket or a parenthesis? Bracket, because I can be -2. All right. Bottoms up. Bottoms up. The lowest the graph goes is 2, and then it goes up until when?
Forever.
Forever. Does it ever stop?
No.
No. How do I say forever? Forever, ever? How do I say forever, ever? Infinity. I'm sorry, I didn't hear you. Okay. Look at number 2. That was disgusting. Gargling his water in his mouth. Aaliyah thirsty, give her a sip. Oh, don't worry, it's just some meat. She ain't in the desert right now, bro.
I am. I'm in the desert. I was actually born at That's the only football games I watch. Football games.
Woo. All right. Look at your paper. Domain.
Yeah, I actually think it is.
All right, domain is left to right. Take your pencil. Up.
3.
Close.
Over 3. Negative 3.
Negative 3. Negative 3. Listen, Max. Negative 3. Is it a bracket or a parenthesis? Bracket. So the smallest my x can be is 3, and then it goes where? Positive 3. Bracket or parenthesis?
Bracket.
These, if there's a point there, it's always going to be a bracket. Okay? Max, take the range. Yeah. D means domain, R means range. I'll write it out. Bottoms up. What's the lowest the graph ever goes?
1, 2,
Negative 3.
1, 2, 3. Okay.
Up to what?
Up to.
Positive 3. That's exactly right. Same thing. All right. Hey. Let's skip over to. Let's do number 7. Looks something like that. This is number 7.
Drawing skills are kind of.
All right, left to right. What is the furthest left my graph goes? Negative infinity. See how it's continuing, right? And it's going to keep going down, but it's kind of inching outward as it goes down. So it's negative infinity. Whoa. It's, It's negative infinity until what? Positive infinity. I've just been doing it so long. How about the range? Bottoms up. Negative infinity. Up to what? What's the highest it goes? Positive infinity. That's exactly right. All right. Let me just talk to you about like number 9 before we move on to functions. These should be really quick for you. They shouldn't be too terrible as long as you can pick up the domain and the range. This one's got a vertical line. It looks like it's at 3. I think that's here. What is the domain? 2, it's just 2, right? X can't be anything except 2. I'm just going to say X equals 2, and I'm going to leave it at that. Okay? Or I could say a 2 in brackets just like that for interval notation, but I'm okay with you just saying that. This is a little exception to the rule, okay? How about the range from the bottom up? That's right. If it's ever everything and there's no stopping it one way or the other, it's negative infinity to infinity. Yes. But it's going to be, the domain and the range is going to be flip-flopped on that one because it's horizontal. All right, flip it over. Yep. I know. We're doing a lot today, actually. Classwork, I'm giving you, yeah. Y'all didn't handle yesterday too well. We're going to go a little bit further yesterday.
No, because you're giving us a lot of work.
The top says functions. I didn't realize yesterday too, whenever I talked to the other Algebra 1 teachers yesterday, I was supposed to make it through that domain and range we just went over. So now this is today's stuff. Go where? Oh, yeah, Phyllis for Smart Pie. All right, functions. Oh, gracious. What is a function?
It's a special rule or law that defines a relationship.
A relation that has one and only one. Huh? That's a little technical for us. We're going to break it down a little easier than that. A relation that has one and only one output. Which is the output, X or Y? Y. For every X. Or for every input. Yes. Now you've got some little hints there that tell you if you have an ordered pair, okay, your x's cannot repeat. If your x's repeat, then it's not a function, okay? You will have questions on the EOC that will say, tell whether or not this is a function. And you'll have a set like number 1, and you'll have to tell them, is it a function or not? So all you're looking for is if it has the same x values more than one time. It's not a function. If it doesn't, then it is a function. It's okay for the y values to repeat, right? But not for the x values. So it's kind of hard to think about. So I'm going to walk you through that, what that looks like. Have y'all heard from him? He didn't? Don't spread rumors to me.
No, that is true.
It is true. I know. I thought Brian's on it. Now let's say. Not like.
All right. So I'm going to walk you through gosh, y'all, I'm sorry my back hurts about every time by the time this class gets here. I need to stand up. I need to get my book. I'm going to walk you through 1, 2, 3, 4 scenarios to tell if it's a function or not, and then I'm going to set you loose, okay? Why are you going to go to the bathroom so much? Why are you wasting all them cheese sticks? Why are you wasting all them cheese sticks? I don't know who asked next.
It was me after me. I don't know who's at the.
You in a bad mood today too?
No.
Why? Oh, leave. Them boys better not be wanting to fight you.
What is that?
All right, boys shouldn't fight girls. Nobody should be fighting anyone. All right. 4 scenarios. Ready? Relation that has one and only one output for every input. Man. Huh? Yes.
I was here. I was really standing right here doing outside the chair.
You got to be in the class when the tardy bell rings.
I was looking for you, actually. I was looking.
You are telling a story because I passed you in the hallway and I said, Aaliyah, where you going? The tardy bell's facing the right. Oh. All right, look. Yeah, my porch is loose. All right. Given some points, let's look at number 1. Number 1's got all these points listed out. 5, -2. 3, -5. 2, -5. 0, -2. -1, -3. Is this a function? Yes or no? Yes, I'm looking at the x's. I only have 1, 5, 1, 3, 1, 2, 1, 0, and 1, -1. The y's do not matter. So I would say yes, this is a function. That is all you have to do for those. These are all yes or no, yes or no, yes or no. Okay? So we look, do any x's repeat? Yeah. If yes, then it's not a function. If no, it is a function. So that's easy, right? Looking just at number 2, is it a function or no? No. Because why? Say it again, Trevor. What happened? The 2 is on there twice, right? You got 2, -4, and 2, 4. I know, because Aaliyah need to go to the bathroom. Right? Look at the next one. Look at number 5. This one looks a little bit different, right? Yep.
No, that name hollow.
What did I do? Oh, there's not a 1 right here. All right, so they said this is no. Why is this no? It has 2 3s, so not a function. Gracious goodness. Okay, so do you understand what it is we're looking for here? Okay. Now, mapping is whenever it's different. Okay, remember what the mapping looks like and what's being done here. All right, so I got -3, -1, 2, and 4. More than likely, they're going to give you one of these because they're the most confusing. All right, here's what I do with these. I write the points down because it helps me see what's going on. Sami, what's the first point in this mapping diagram? -3 and 0. Max, give me the next one.
What?
Give me the next point in this mapping diagram. I got -3, 0. What's the next one? -1, 4. All right. Dustin, what's the next one? 2, 7. What's the next one? 4, 4. Is it a function? How do you know? None of the x's are the same. So yes, this is a function. Same thing. So every time you're looking at do the x's repeat, do the x's repeat, do the x's repeat. Okay. All right. Well, they won't repeat on here. If this is what, like, look at number 10. See how the -1 has 2 arrows coming from it? That's a repeat on x. Do you see what I'm saying? So that's a no. Number 10 is a no, and let me show you why. Why, Jose? Tell us. All right, give me the points. -4 goes with what? -4 goes with 4. -1 goes with what? 0, but it also goes with 7, right? Because there's also a line here. So that means x is repeating there. Does that make sense? Do you see how we're getting that? All right. You say, huh? All right, this -1, it's mapping to 0. That's this point, but it's also mapping to 7. So if I were to write those points, I would have to write that -1 twice. Does that make sense? All right. The last one I want to show you is not on here, but I do want you to write it down somewhere on here. And that's if I have a graph. In fact, flip back over to the page before. This one with the pictures. And I want to talk to you for just a second. To check a graph, meaning you have the picture, can you tell if it's a function or not? We use the vertical line test. Now, let me show you what I mean by that, okay? What's wrong? We flip back over to the other side where we started. I'm just kind of putting a couple of what these look like. Let me actually. These are already drawn for you. All right. For 8 different graphs here. Take your pencil, hold it vertically. Up and down, up and down, up and down. Put it on the graph at number 1. Will it ever touch? I'm just looking at this one. Will it ever touch more than one time? More than once at one time? No. It never touches more than one time. So yes, this is a function. Okay, watch with, let me show you one that's not, and then we'll talk about comparing them. Right, look at the circle. What happens if I put my pencil right there? Do you see it's touching twice? If this is my pencil laid right here, there's my pencil, here's the eraser, it's my pencil right here, right? It's hitting it 2 times. Yes? That means it fails the test. It's, oh, stepped on it. Ain't gonna have
flat, but every time it stops working, it's like this.
This is not a function. Do you see the difference? If I put my pencil here, there's nowhere that I could drop my pencil and it hit more than one time. It's always only going to hit once. But it's got to be straight up and down. You can go.
Answers like these. Why would you put yes if it's not? Why would you put no?
If it passes, it's yes. If it fails, it's no. That's just how you tell. When you're thinking about the axis itself, not the axis on the graph. So don't look at that y-axis part of the graph. It's not. I'm just coming here.
If it doesn't touch, wait, no.
If it doesn't touch, then it passes. In order to pass, it can only touch once. If it touches more than once, it fails. So I'm saying, yes, this is a function. No, it's not a function. Look at this one. Look at the third one. Function or not? Yes, it's a function. Because it only touches one time. Look at the next one. Max, function or no? Yes, it's a function. Why? There you go. No, you are on fire with this. No, it's not a function because it touches twice. That's right. If I drop down right here, it touches twice. So it's not a function. Yes. Yes. What about the last one? No, look, drop it right there. Okay?